Homework 1c. Question number 1. A gas at 250 Kelvin, 15 Pascal, and the volume, molar volume, is 12% smaller than calculated from ideal volume, and that means it's 88% of the molar volume calculated from ideal volume. So from this information, we can calculate the Z factor, which is the real volume divided by ideal volume. Real volume is 88% of ideal volume. So ideal volume cancel each other, you get 0.88. It asks you to calculate the molar volume of the gas. So we use gas law, which is PVN equals ZRT. Here Z is 0.88. So from here we calculate the molar volume to be 1.2 times 10 to the minus 2 cubic meter. So cubic meter per mole. All right, that's the real volume. Now, next question is, what force dominates the sample, attractive force or repulsive force? Because the volume, real volume, is only 88% of the ideal volume, that means the volume is smaller than the ideal volume, which indicates attractive force dominate. Question number 2. Calculate the pressure exerted by argon for a molar volume. This is the molar volume, 1.42 liter, and the temperature 300 Kelvin, using Van der Waals equation of state. So Van der Waals equation is here, RT over Vm minus B minus A divided by Vm squared. And so plug in all the data, all right? So A and B are given here, all right? And now because the A and B constant unit is bar cubic decimeter, okay, to the 6th power, so we choose the R factor or R constant in terms of bar and liter. So 1 liter equals 1 cubic decimeter. So the number is 8.314 times 10 to the minus 6. So that will give you 17.3 bar. Okay, and it asks you what force dominate. Now to find out what force dominant, one way is to compare the pressure with ideal pressure. So if a gas behaves with ideal, what's the pressure? We use ideal gas law. So we have the volume, gas constant, and the temperature, and the calculated pressure is 17.6. Because the pressure is smaller than the ideal pressure, and that indicates attraction force dominate, because attraction force reduces pressure. Question number 3. A certain gas obeys the Van der Waals equation. A is given. Volume is known. So A, this is volume, molar volume, and temperature, pressure. So it asks you to calculate B. Okay, so you start with Van der Waals equation, and you need to calculate B. So modify the equation, all right, and plug in all the data. So B can be calculated. Now, what is the compression factor for this gas? So compression factor, if you know the volume, real volume, ideal volume, you can use the definition. Now you can also use PV equals ZRT if you know pressure, volume, temperature. So that's the case in this question. So the Z can be calculated, which is 0.66. Question number 4. The critical constant for ethane are given, and we want to calculate Van der Waals parameters of the gas. That means we need to know what is A, what is B, and we want to estimate the radius of the molecule. So Van der Waals equation theoretically predict this equation. That's the critical constant. Okay, critical volume, pressure, temperature as function of A and B. So from first equation, we can calculate B if we know VC. So the critical volume, and we can calculate the constant B. Similarly, using second equation, we can calculate A. Okay, so AB can be calculated. So next is ask the estimate the radius of the molecule. So which one is related to the size of the molecule? It's the B. B is due to the repulsive force. The volume of the molecule, all right, is not as accessible to other molecules because of the repulsive force. So B is excluded volume of a molecule, of a spherical molecule. So if this molecule 1, this molecule 2, so the volume volume that the second molecule cannot go is this volume. All right, so the center here, all right, so center of the second molecule cannot go inside. The volume is not just radius, but 2r. Okay, it's 2r. All right, so so what's the volume? 4/3 pi r to the third power. That's the volume. Here r is 2r, so 2r goes in. All right, so that's the volume of one molecule. Now B is 1 mole, so you need to times Avogadro's number. So here is Avogadro's number times the volume of one molecule. All right, the excluded volume of the molecule. So not just the size of one molecule. The radius is 2r here, and so modify the equation. We can calculate the radius r if we know B constant. So plug in, and answer is 1.34 times 10 to the minus 10 meter. Last question. Suggest the pressure and the temperature at which 1 mole ammonia will be in state that corresponds to 1 mole hydrogen, 1 mole or 1 atmosphere, and 25 degrees. So we know the state of hydrogen. All right, we want to know the pressure temperature for ammonia to be in the state of corresponding state. Corresponding state means they have the same reduced temperature, so reduced pressure. So we need to look at hydrogen, calculate reduced temperature pressure. But first we need to find the critical pressure, critical temperature, and then calculate reduced pressure, reduced temperature. And so that's for hydrogen. Now for ammonia to be in the same corresponding state, then it should be the same. All right, and so that will be pressure of ammonia divided by critical pressure of ammonia, and therefore this can be calculated by critical pressure times reduced pressure, which is this one. So for ammonia, you find critical pressure, critical temperature, and then calculate the pressure, and then calculate the temperature. So